If you are currently leveling up your Django and Postgres skills with this tutorial, you might like to know that this tutorial is part of a whole playlist where you will learn how to, with Django and Postgres, create database level constraints and triggers. If you like this playlist and you would like to learn more about Django ORM, then do check out our Django ORM Mastery course on Udemy. Links to the playlist and course can be found in the video description. Okay, so now we get to the main event, defining the constraints and triggers for each of our table in our database. Similar to the previous module, I will take you through this process step by step, every single table. The idea here is that I would take you through each table as and when you start to become or feel a little bit comfortable, potentially you can complete this task yourself. You can go ahead and practice applying what you have learned on the other tables. All the information that you're going to need is here in the constraints and triggers table. Once you familiarize yourself with how to actually create the check unique constraints and triggers, like I said, you can go ahead and try to apply that on the other tables. What might need a little bit of explanation is the why. Why am I actually doing this? And this is where you need to try and remember that this is just a made up project. I'm just trying to show you some of the skills, techniques that you might like to utilize on your database. But I will always try at the start of a tutorial, give you a little bit of context to help you understand why it is that we're applying these different constraints and triggers to each table. Although after a certain point of time, it will become very repetitive. So let's get started with the category table. We have a number of different constraints and triggers to define. Don't forget we have the data dictionary here at the top, which defines the properties, attributes of each field in our table. So let's take a look at the constraints. So we'll work with this one by one. We'll start with the top, name, we'll go to slug, name, level, and level. Right, so let's start with the name. So we're going to need to build a check constraint to ensure that the field is not an empty string. So we're going to try and prevent empty strings from being inserted. Now, this might be a little bit confusing because if you remember, if we take a look at our data dictionary, the name is actually set to null, indicating that we cannot actually insert null into this field. We actually have to populate this field when we insert a record into this table. However, what's important in PostgreSQL and many other relational databases, there is a distinction between null and an empty string. Okay, so the not null constraint that we have applied here ensures that the column cannot have a null value, but it does not prevent empty strings from being inserted into text or character columns. So we have to be careful there potentially to try and capture that to ensure that if we do or somehow an empty string is inserted into our database, then we want to capture that and ensure that doesn't happen. So just to reiterate that, the null will represent the absence of any value. It's a special marker in the database used to indicate that the data value does not exist in the database or in this field. So the empty string represents a string of 0 characters. So it's a valid string value that contains no characters. And at the moment, we've set the name field to false, so it cannot be empty. So we have to actually add some sort of value into this field. So it cannot be set to null, this field. But we need to remember that it can also represent a string with 0 characters. And that's what we want to try and avoid. Now, let me just quickly show you an example of this. I have migrated the tables to the database. You don't need to do that. This is just an example. You can see here that I've tried to add some data into the category table. So I've added a new record, and you can see where the parent ID is set to true. So it can include null values. Where we don't actually enter a value into that field, you can see it's set to this value of null here. So the database automatically does that. And you can see here that when I entered this record into the database, I didn't include a field, a name. And you can see here we have an empty string in the name field. You can see it's completely empty. remember that the name is set to not null, so we have to actually insert something into this field. And when, in this case, I add data using a form here, this is actually adding an empty string. So I just add something else again. You can see that add the level that's required. So when I press save again, you can see that we have this empty string again. Parent ID is null, and we have the name empty string. Obviously, we want to avoid that. Now, I say we obviously want to avoid that. That might not be so straightforward and obvious. So when we insert data into a database, we want to make sure that our data is meaningful and also consistent. So an empty string does not necessarily offer or provide meaningful information. For example, in this case, the name is empty, so it doesn't help identify the user. So by using null instead of an empty string, it helps maintain data integrity and consistency across our database. And also, null is something we can actually query, although we can query empty strings, but it is something that we can easily query. So when we run a query, select all categories where parent ID equals, we can use null in the actual query. And advancing from that, when we start to think about validation and logic, allowing empty strings can complicate validation logic, both at the database level and at the application level. Now, more obviously, for the category table, this is going to be really useless to have a record that doesn't have a category name. So let's make sure we avoid any empty strings. Now, let's remember, we're trying to work at the database level to create this validation, but just to let you know that it is possible to actually create validation within our model. Now, I've gone ahead and added blank equals true. So if we were to try and, for example, create a form, maybe use the Django admin site and insert data into the category table, blank equal true is going to check to ensure that the name field is not an empty string. Now, another approach in Django is to override the clean method. You can see here in this code, I've overridden the clean method and I've created a validation check to check if self name, so if the name field is an empty string. If it is, I'm going to raise a validation error. I will leave this in the code base. When you download the source code, that will be available. So I'll leave that right there for you to inspect, but I will remove it in further updates of the code. So our goal remains the same. We're going to create a validation check on the database. So how on earth are we going to do that? Well, the first thing that we could do is simply just migrate all of our Django models, go into our Postgres database, and just manually add them into the database using SQL, Structured Query Language. Okay, so let's just talk about the approach that we're going to take to actually create our checks in the database. Now, what we can do is we could go ahead and migrate our models, and then we could go into the database and we could use SQL code to actually create the check constraints in the database. Now, the problem with this approach is that whenever we reset our database and then migrate it again, we would have to manually go into the database every single time and reapply the SQL to add the check constraints for each of our tables. And there's quite a few tables, there's quite a few check constraints and other constraints that we need to apply. So this isn't probably the best approach. So the second approach we could utilize. So here we have a check constraint that's been applied within our Django model, in this case the category table. So you can see here in the meta, I've added constraints. So as of I think it was Django 2 point something, it introduced check constraints class, which allows us to define database level check constraints directly within our models. So you can see here I've tried to set up a check constraint. So I check the name field, make sure it's not empty. The process from this point is very simple. We have all the code within our model. We go ahead and make a migration. Through that migration process, the SQL code is generated to create a check constraint once the category table has been created, and then the check constraint is applied to our table. This can be a very clean approach, and it does utilize Django's tools. So this can be a very comfortable approach to take. Now, there are some drawbacks to this. Remember that we are specifically using a Postgres database. So having this type of code here means that we are then locked in. This code base is then locked in to the Postgres database. Of course, that might not be a development now because you know you're going to be using the Postgres database, but in the future, you may make changes. Another point to note is that some check constraints can be quite complex, and Django doesn't always provide all the tools that are needed for this complexity. So what ends up happening is that you define some constraints in your model, and then you have to define some constraints or manually define them somewhere else. And at that point, things start to get a little bit messy and less manageable. A more complex view of why potentially you wouldn't include constraints directly in the model is the principle of separation of concerns, which states that different parts of software should have distinct responsibilities. In Django, models represent the schema of the data and its business logic. Now, we could say that this constraint is part of this business logic. However, this constraint, if you think about it, is code which is going to reside at the database level, whereas all this other code here is primarily going to be utilized with the application layer. So what we have here is potentially violation of this principle of separation of concerns, because we have database code and application layer code in the same place. Now, generally, we always search for the best approach. I'm always asked, what is the best approach? Well, it depends. That is the answer most of the time. I'm just showing you at this point some of the different approaches which you can then choose based upon your particular project setup. Okay, so the approach that we're going to take, and this really is an approach which I think aids our learning of Django. We're going to explore a little bit more about the migration file. So we have our Django models. We probably are already aware that in order to actually convert our Django models into actual tables in our database, we're going to need to run a migration. When we run the migration process, it creates a migration file. Now, what we're going to do is within our migration file, we're going to manually add the code that's needed to actually build the different constraints and triggers. Now, remember here, the important bit in this project is that I already have all the specifications defined. I know the starting point in my project. I'm not going to need to move back, not going to need to roll back. I'm not going to need to remove or make any changes. I'm certain that this is the approach I want to take. So we're going to add this code into the migration file. So when we migrate, the checks, the triggers are all going to be applied into the database. Now, what we're going to be doing here is create a migration file. We're going to be building a migration file for every single database table. So we're going to work table by table. So at the end of this process, we will have 10 migration files for individual tables, which includes all the different check, unique, and trigger code that's needed to generate those database level validations. Okay, so that's the plan. Let's get started. Right, so first of all, let's just make sure that we comment out all of the code in our models except the category table, because we want to work specifically with the category table. So we're going to work table by table from this point onwards in this module. So once we've done that, let's just make sure that we are in the right directory. Yep, so we should have the, oh, we're not, here we are, oh, we're not. So let's change directory to Django inventory. So we should have the manage.py file, good. Right, so let's go ahead and make migrations as per usual. And you can see we've created a new migration file. If we go into our projects in the inventory app, migrations, we should now have one file. Right, so there's two approaches here. You can either rename the file manually, category, or else, if you prefer, if I just remove that, you can make migrations and just use the name flag. Let's call that category, and there we go. So there's two ways to create this named migration. So let's take a look at what we've got so far in our migration. So you can see here that we're going to be migrating this table. It looks as though we have all the fields identified, as well as some of the different constraints related and properties and attributes related to each field. Because we live in a world of no-code solutions and services, if you were to ask ChatGPT to generate the code here that's needed to create the validation in the database, there is going to be potentially two approaches provided. First of all, it's going to try and utilize some of the Django API tools to generate the code needed to generate the validation. So here's an example of a Django approach to generate the check constraint. And this would be a valid approach to actually generate the check constraint at the database level. This would get translated into SQL code by Django and actually applied to our database. Now, the problem with this, I find, is that you end up wanting something a little bit more complex, and certain constraints will be too complex to express using Django's check constraint. So we end up using raw SQL, and then we end up having a mixture of the Django expressed constraints and then the raw SQL, and it gets a little bit messy. So I prefer just to use one approach, and that approach in this case is going to be utilizing raw SQL. Now, in the past, I probably wouldn't be recommending this in this learning journey, but because we now live in the world of no-code solutions and services, it's going to be easy for us to generate the raw SQL that we're going to need to actually apply this check constraint on the database. Using raw SQL will give us that greater control and mean that when we need to, it will also supply that performance optimization capabilities. Now, one last consideration before we apply this is that typically the migration, we always want to be able to move forward and backwards. So we want to be able to migrate, and we also want to be able to roll back. Now, in this instance, because this is the starting point for our application, for our database, I'm not going to be talking about reverse SQL, actually being able to revert back, because this is going to be our base. The code we're making here, the migration files we're building here, this is going to be our base migration. And any migrations after that point, if we do make any changes, we might want to consider when we add SQL or any customizations, we might want to consider the fact we want to migrate and have the potential to roll back. So within our migration file, typically in this scenario, we would define how to actually apply the changes and how to reverse them. But like I said, in this case, because this is our starting point, we're not going to do that. Right, so let's get going. Right, so to find where we need to add this is the migration file for the category. Hopefully you've created yours if you're following step by step. Now, so we have operations. So let's see where that ends. The operation ends right here. Yes, no. So yes, yeah, fields. So that's the fields. That's the first migration create model. So you're looking to add just under here. So we end the first function, and now we're going to add now the custom SQL. So let's do this manually, and then what we'll find with other tables, I'll just lift the code in because it's going to be the same. So migrations dot, and then we're going to run some SQL. Right, so there's a few ways to define this. We're going to use the triple doubles. So let's move this across. So triple doubles. So this is SQL. So we're going to run some SQL code. Now, I appreciate that you may not be familiar with SQL code. So first instruction we're going to provide is alter table. Notice it's in capitals to indicate some sort of instruction. So alter table. So we need to first of all identify the table that we're going to need to alter. Category. So the inventory category table. We'll do this line by line, command by command. So add, we want to add a constraint. Now, when you read this back, it just makes, hopefully you'll see it just makes sense, really. It's just in plain English. If you are English, that Makes it a lot easier to understand. So we're going to set up our add constraint. So we're going to add a new constraint. What we're going to add a new constraint to? Well, inventory category. So here we're just adding the name for the constraint. So this is just the name that's going to be included or related to this constraint. So let's call this inventory category check empty name. Okay, so that's the name of the constraint. And now let's go ahead and add the constraint code. So we want to make a check. So we want to check the name and is not equal to blank string. And while we're here, we can say and name is, we don't need to do this, but I will do anyway, and name is not null. So we can do two things at a time if we like, and we can add more there if we need to, just to kind of showcase that. And there we go. So that adds our check constraint. So this code here is actually going to be added to the database and used whenever we try to add a new record to this database. That's going to be triggered, and it's going to run the check on the name field to make sure it's not blank. We now have our first constraint defined. So all we're going to need to do now is just test this out. So I'll take you through the process of migrating to our database, and then we'll have a look and inspect it at the database level. Now for this, you need to remember, and I'm making the assumption that you have been following along in this course, you will need to actually run Docker Compose. So you will need to have your database running in the background. I'm going to make the assumption you know how to do that, and your database is running. It is fresh and ready for us to run the migrations. So let's go ahead and actually now run the migrations. So manage.py, and then we're going to migrate. Now remember, we don't need to run migrations, even though we've changed the migration file. So we just need to run migrate. That should now migrate everything, including the category table, to our database. Right, so now we can move across to AdMiner, and we can run a refresh on that. So make sure you select the inventory table. You can see that we have our inventory category table now inside of our table. So let's have a little look at this. So, okay, so we can't identify the fact that the check constraints are defined here at this level with this interface, but what we can do is run an SQL command to check to make sure that it has been set up correctly. If you take a look at the source code, you will find the docs folder. In commands, you'll find PostgreSQL.md. Right, so in here, I've just added some of the different queries that we can run to gather some information about the constraints that we're going to create. So here, this is going to return all the constraints for a particular table. I've already added this in, so you can see inventory category is the table. You'll need to change that if you want to work with different tables. So I'm going to copy that. Let's go back into the table. So I've currently selected the inventory category table. I'm going to go to SQL command, although that doesn't really matter because we're running this. So I'm just going to paste that in there, execute, and there we go. So we can now view all the constraints related to the category table. And you can see there's already quite a few. Because remember, I mentioned that some constraints are automatically created. For example, foreign key constraints. You can see that you can actually see the empty name constraint that we've just generated. You can see the primary key constraint that's automatically generated when we build the table. And it looks like we have this slug key constraint as well. Because remember, this field needs to be unique. So you can see these letters here indicating the type of constraint. We have a C for check constraint. We have U for a unique constraint. These constraints you can read about in the documentation. We have a P, a primary key constraint. If you remember, I think I gave you a list or presented a list of all the different types of constraints. And this was a foreign key constraint. So you can see that these were automatically added when we added when we migrated the tables. And you can see the C, the check constraint, that's what we've just created. Now, if you want to get a little bit deeper, I'm just going to paste in there the check constraint name. So we can now run this second query here, which will then show us the actual check constraint code. So let's go back into our SQL command, execute that, and it looks like we can now see the constraint definition. So you can see this is the actual code that the database is using to actually assess whether the text is empty or not. And you can see that it does loosely relate to what we've typed in terms of the format that we applied in our migration file. We have two constraints. Here we're testing for empty text and is not null. Okay, so now we just need to test this out to make sure it actually works. So let's go into inventory. Let's we'll go into the category table. Let's add a new item. Now, before I showed you an example of the fact we could add the empty string into the name. So let's see if we can actually still do that. So we're going to need a slug. Remember, that's unique, and I think it is required, and level, that's required. So when I press save now, there we go. So it says there is a new row, a relation inventory category violates check constraint. And that's our check constraint we created. And obviously the problem is that we have an empty name. So if I add something into a name and press save, you can see everything is working as intended. So that's our first constraint now applied in the database. We simply need to now roll that out for all the other constraints. All the other tutorials obviously won't take as long because there isn't as much explanation. I did most of that work in this tutorial. So let's now move across to building the trigger